Is the Great Salt Lake a potential source of greenhouse gas emissions? Scientists indeed identify the Great Salt Lake as a significant source of greenhouse gas emissions. Hello friends, Jim here. So what's going on? Well, we have a picture here of a researcher sampling gas emissions from the lake bed of the Great Salt Lake. Research by the Royal Ontario Museum, examining greenhouse gas emissions from the drying lake bed of Great Salt Lake, Utah, calculates that 4.1 million tons of carbon dioxide and other greenhouse gases were released in 2020. This research suggests that drying lake beds are an overlooked but potentially significant source of greenhouse gases, obviously leading to further increase on the climate change being experienced. The results were published in a paper. A desiccating saline lake bed is a significant source of anthropogenic greenhouse gas emissions, published in the journal One Earth. Human-caused desiccation of Great Salt Lake is exposing huge areas of lake bed and releasing massive quantities of greenhouse gases into the atmosphere, said Soren Brothers, who led this research and is the ROM's Alan and Helene Schiff curator of climate change. The significance of lake desiccation as a driver of climate change needs to be addressed in greater detail and considered in climate change mitigation and watershed planning. From year to year, Great Salt Lake's water level varies, largely depending on the volume of meltwater that flows into the lake from the surrounding mountains, from record highs in the 1980s to a record low in 2022. However, it is human-related consumption by agriculture, industry, municipal uses that consume ever-increasing amounts of fresh water that over the years has depleted the lake. Elsewhere around the world, these same competing uses for water are having a significant impact on lake levels. As iconic saline lakes such as the Aral Sea, Lake Urmia, the Caspian Sea, and the Great Salt Lake dry up, they not only destroy critical habitat for biodiversity and create air quality conditions that deteriorate human health, but they also accelerate climate change, as newly exposed sediments emit CO2 and methane. Now, a little something about this here. Create air quality conditions that determine human health. What I think they're getting at is with the exposed sediments and you have wind activity, that there are certain heavy metal pollutions that are getting thrown into the atmosphere, becoming airborne, such as arsenic. And that, of course, exposes humans to other dangers. I did a video on that a little while ago, so if you haven't seen it, you might want to check that out. So the research team measured carbon dioxide and methane emissions from the exposed sediments of Great Salt Lake, Utah from April to November 2020, compared them with aquatic emissions estimates to determine the anthropogenic greenhouse gas emissions associated with desiccation. Calculations based on this sampling indicate the lake bed emitted 4.1 million tons of greenhouse gases to the atmosphere, primarily, they estimate, 94% as carbon dioxide, constituting an approximately 7% increase to Utah's human-caused greenhouse gas emissions. Yep, here's Great Salt Lake. Dried up beds. Fieldwork was conducted while Soren Brothers was assistant professor of limnology at Utah State University, and lead author Melissa Cobo was a master's student at USU. Co-author Tobias Goldhammer is a collaborating researcher at the Leibniz Institute for Freshwater Research, IGB, Institute in Berlin, Germany. Measurements of CO2 and methane gases were made every 2 weeks from a dried up lake bed using a portable greenhouse gas analyzer attached to a closed chamber. 7 sites at one location at the south end of the lake were visited repeatedly over the course of the year, and another 3 locations were sampled during an intensive 3-day campaign to determine spatial variability across the lake, which at 1,700 square miles or 4,400 square kilometers is the largest saline lake in the Western Hemisphere. As methane is 28 times more powerful greenhouse gas than carbon dioxide, the global warming impact of these emissions was calculated as carbon dioxide equivalents to account for the greater impact of the methane. Ultimately, these data indicated that greenhouse gas emissions from the dried lake bed were strongly and positively related to warm temperatures, even at sites that have been exposed for over 2 decades. To determine whether the lake historically would have been a significant source of greenhouse gases, the team carried out measurements of nearshore greenhouse gas emissions from the lake, as well as analyzing water chemistry collected by the team and government data sites. Together, these analyses show that the original lake was not likely a significant source of greenhouse gases to the atmosphere, making the dried up lake bed a novel driver of atmospheric warming. As climate change exacerbates drought in arid regions, desiccation of rivers and lakes may be contributing to climate change feedback loops and should be considered in assessments of global greenhouse gas output as well as reduction policies and efforts. This last paragraph summarizes the importance of this research. That as desiccation exposes more riverbeds, lake beds, then they could become a source of greenhouse gas emissions, adding to the carbon budget of the atmosphere. So therefore, implying our measurements, our estimates, could yet be another underestimation. So that is an important part of the significance of this finding. So just a short video to bring you this latest information, and shows some more of what humans have done to planet Earth, and how our nearly 300-year global geoengineering experiment is now coming home to roost. So, until next time, thank you for your time.